Did you know that Moodle near is French?
All right, so let's real quick. There's kind of a mixture. Kind of a mixture of issues with maybe just some kind of just minor stuff, and then maybe a couple comprehension things going on. So if we want to do something like this, we want to write the domain of that function using interval notation. What's that going to look like? Well, what's interval notation is which one? Okay, we're going to get some grouping symbols and a comma in between the left and right endpoints, right?
Yes.
And domain's an X issue. So then what's this going to look like? We're going from, everybody see that? Yeah, we're going to go from -8, what kind of symbol? Round. And then 6. And then square. Okay, is there a question about how to input that into Moodle? Okay. You do. All you have to do, if you want to do what's called a semi-open interval or a semi-closed interval like this, where you've got one open and one square, is when you go into Moodle, if you just type like the open brackets, it's going to open up a second one for you, and then it's going to put the cursor in the middle. But after you've typed what's in the middle, if you just hit the right square bracket, it'll replace that last parenthesis with a bracket.
It will?
Okay?
Yeah.
Okay? So there's that one. How about something like this? Now write the range of the function. Yeah, I got a lot of them on here that were flagged as if there was something wrong with the question, and it was just one minor mistake. What do you think people did on this? What do you think they might have done?
The domain.
They wrote the domain, or they wrote the range, but they wrote it in terms of the wrong variable. Range should be in terms of which variable?
Why?
Okay, so then if we want to write this using, well, actually this one's using interval notation, so it shouldn't matter. But what would the range be in this case? That makes sense. We're looking on the y-axis, right? So the bottom limit is going to be, or the bottom endpoint in this case is going to be literally the bottommost endpoint. It's like we're looking sideways on this, right? And we can see that right here is the lowest y value. So if we were to graph this on the y-axis, think of it as taking this whole function and just smushing it onto the y-axis. Well, where would it end up? You'd end up with a solid circle there and a solid circle there, right? Because those are does that make sense? Okay. Hey, Andrew, what's up? Oh, yeah. Here, let me get that for you. I'll send it right to you. Okay. If their names are on that list, then it has to be like caps lock or something. Yeah. Okay. Hold on. Give me one sec. Get something in the teacher. All right. So anyway, so we're gonna put this in then as solid brackets, just going from -8 up to +6, right? Right. Okay. What about this? There's a little question on this guy. I guess I understand why. There's something important here that we got to maybe spend a little time talking about. The red line is an asymptote. What's an asymptote?
Yes, sir. Never reaches it.
Never reaches it. Yeah. Okay, good. If you run into something like that and you're not sure what it is, what's a good suggestion about what to do? Google it. Exactly. I Googled it. Great
I know
idea.
I handle my life.
Okay. So what about this then? Says what is the range of the function then? Up to, okay, -1. We're going to write this using interval notation. What do I have to do at -1 though? It's got to be open because it's not included, right? The function is rising, it's rising, it's rising. It never quite gets to -1, okay? So we end up with something like this. What if we wanted to write, because this is going to come up again, you see the same kind of graph. What if we wanted to write, for example, the interval on which the function is increasing. Let's say as an inequality. I think I asked you to write that one as an inequality. So where is it increasing? Where is this function increasing? What do you think, Ruby? Where is this increasing if it never actually gets to that line? So where, in other words, what do you think, Kristen?
From negative infinity to 1?
And I can see why you think that, because it looks like it just kind of stops there, right? But if with the asymptote, it never touches the asymptote, what it's always doing is getting just a little bit closer, right? So it's the same kind of thing as me stepping towards the door and cutting my distance in half with each step. So you want to amend that answer?
Negative infinity to positive.
Exactly. So it increases more and more slowly, and after a while it increases just, the rate at which it increases actually approaches zero. But it is always increasing, right? And so it's increasing on the interval from, if I wrote it as an inequality, x is greater than negative infinity and less than infinity. Okay. Where is it decreasing? Nowhere. Yeah. Okay, what about this, right? The range as an inequality. A lot of people miss this one for a silly reason. What they do? They put x instead of y. So what should it look like? Y is what? Greater than or equal to, right? Negative 2 and less than 6, right? Because it doesn't actually, the y value never actually gets to 6, does it? Oh, positive 2. You're right. Thank you. Thank you. Okay, now what if, I'm just going to do a little what if here. What if one of these endpoints was filled in but not the other? Say it again? Then it would include 6, wouldn't it? Because the y value of 6, even though you didn't have it there, you did have it there, right? So the y value of 6 is included in the function. So if we fill that in, we'd have to do that, right? Okay, let's see here. Any questions? Seems like I'll just pull this guy up. Okay, any questions on this one? So what if we want to do something like that? What if we want to vertically stretch this function by a factor of 5, reflect it over the x-axis, and translate f of x 5 units right and up 6 units? That's a lot of stuff. Let's take these one at a time. What am I going to do? So if I want to vertically stretch, I'm just going to fill in the blanks, right? So if I'm going to vertically stretch, what does that part do? I'm going to put a 5 out front. Let's do them one at a time. So I got a 5 out front of my function, okay? And then I'm just going to write the function in there, and we'll add stuff to it as we need to. So we've got the 4th root of x to start with, right?
Yeah.
Okay. So we took care of the vertical stretch by multiplying by 5. Let's see, Kirk, how am I going to, in addition to stretching it vertically, reflect it over the x-axis? Okay, going to multiply the whole thing by -1, so now I get a -5 out front, right? Gabe, how am I going to translate right by 5 units? Good, okay, so inside the function, I'm going to subtract 5 from x. And then last one, Katie, how am I going to translate it 6 units up? Okay, good. Outside the function, we'll add 6. Make sense?
Yeah.
Okay? First try. How about that? Okay, let's see. Anything else here? This one would be, this is the same deal, only it's not a specific problem, right? So we're just going to write this literally. G of x is going to be written in terms of f of x. We don't even know what f of x is. Okay? Same idea, though. Okay. I think I think that one probably, that was like the hardest one. What would you do? Find one more here that's just in terms of a different function. How about this guy? Let's do one of these. We're going to call her good for this assignment. So we start off with f of x equals this exponential function, 8 to the x. Does it matter that we haven't done a lot of work with exponential functions? No. I could have given you a hyperbolic tangent function, and it doesn't make any difference whether you've even seen it or know what it is or not. When you're doing transformations, you're just writing the transformation in terms of whatever the original function was, right? Okay, so we're going to write this in terms of 8 to the x. Okay, Emma, if I want to vertically stretch this by a factor of 5, what am I going to do?
Okay, I might not remember this very well. It's either the 5 in front of the 8 or in front of the x.
In front of the 8, right?
Yeah.
Because if we're vertically stretching it, it goes in front of the whole function.
Yeah.
So we're going to do a 5 times, 5 times. And what about reflecting it over the x-axis then? What's that going to do? Got to put it, I'm going to make multiply the whole thing by negative, so it becomes a -5 again. And if we want to translate it 3 units up, Ellie, what am I going to do to translate the whole thing 3 units up? +3. Okay, good. Let's make sure, I'd like all like phones and things like that to be put away, please. Okay, make sense? Okay. And yeah, I think we're good. What would I do if I add an additional part of this that says I'll just go back to the last one. What if on the last one we also wanted to move it 4 units left? What else would I do? Where would I put where's the 4 units left go? Okay, with the x, good. So then we'd have to go up here from x, we'd subtract -4, right? So if we're going left 4 units, we'd add 4 right there. That make sense? Okay, good. All right, so okay, how about this guy? Writing inverses. Okay, this is pretty straightforward. I'm going to move up to one of the nonlinear ones. I think I gave you 3 linear ones. Oh, here's one. Okay, so what are we going to do here? If I want to write the inverse of this, what's that going to look like? What am I going to do? What's the process? Step 1. Okay, trade y for x. So we're going to rewrite this as y, or excuse me, write it as y first. Sorry. Y equals x to the 11th. Step 2, Elizabeth, what's the next step? After I just trade my f of x for a y. I think I fooled you because I said I was going to switch them, but I haven't done that yet. So now I switch them. Good. So we get x equals y to the 11th, and then the last step? Solve for x. Well, how do we do that? How do we undo y to the 11th? 11th root. Yeah. So y equals the 11th root of x, and then I want to write that as f inverse, so that's what I'm going to enter in there, right? Okay, no big deal. I did give you one that's a little tricky on here. I want to just take a second and talk about that. So what if we do, not that one. That one's kind of the same thing, isn't it? I've just got more to undo when I solve for my new y. Just got to follow a reverse order of operations. But this one, it's a little strange. What about that guy? Let me take a picture of that. Okay, so what do you think? Step 1. Okay, trade the f of x for a y. So we get y equals x to the 10th minus 7. But look what it tells me. It tells me that the domain is what? Yeah, okay, x is non-negative, right? 0 or positive. So I'm going to include that in everything we do. That's important. That domain is a part of what we're doing. So x is greater than or equal to 0. Step 2. Okay, flip x and y. Now look what that does if I flip x and y. So this becomes an x, that becomes a y. What happens to the domain?
It's a Y.
It becomes the range, right? Isn't that what we do when we take an inverse? We're interchanging the domain and the range. So this statement becomes now y is greater than or equal to 0. Okay, that's going to be important. How do we solve for y? What are the 2 steps in order to solve for y? Matthew, what do we do to get that y by itself?
That's 7.
Add 7, good. Then what? Take a 10th root. Okay, so we end up with y to the 10th equals x plus 7. We got to be careful when we take an even root of both sides. Remember what we said we have to include, plus or minus. So we end up algebraically getting the answer y equals plus or minus the 10th root of x plus 7, right? But look at our domain. Our domain includes only positive values. So which of those signs do you think that we're going to keep in this case? The positive, right? So our answer, when we combine our domain with our answer, with our solution, we end up getting y equals only the positive. Now, what if that had been negative? Then we would have kept the negative sign, right? So we just get positive 10th root of x plus 7. Okay? We'll come back to that later in the year and talk more about that. But for now, those are just the rules that we follow. Okay. Oh, I think that's it for you guys. Oh, did we want to go through, there's on this last assignment, I think there were a few questions. You guys can decide if you're ready for this or not. I'm willing, if you want to, do we want to go through a sample problem on this one? You want to just go? Okay, how much time we got? We have time, don't we?
14 minutes.
Oh, yeah, we got time. Okay, let's go down to 205.